Good afternoon, all. This is Hark Halliwell from Taggle Systems. Thank you for joining in this afternoon. Hope this is going to be an interesting webinar for you. It's a little different to what we've done in the past. It's perhaps a little bit more technical, but it does go to the heart of what we do at Taggle, because the whole of our business is based on the Taggle radio network that we operate. So I'll just wait a couple of moments while some stragglers join in. There's not so many people this week. I guess everyone's busy doing stuff, which is kind of understandable. Before I get started, I should perhaps engage in a little bit of housekeeping. No, the exits aren't behind you on the right, and the toilets aren't available. But what I would like to say is that if you have any questions, please feel free to ask at any time. I note that you're all muted, which is great because it cuts out the background noise and the echoes. But if you do have a question, please feel free to ask the question, or indeed just type it into the chat page, and I'll try and keep an eye on that as we go. So that said, I've waited a couple of minutes. A couple more people have showed up, so I'll get into it. So moving on. Here we go. A quick introduction. Well, I've introduced myself, Hark Halliwell from Taggle Systems. We've done the webinar admin. You all know where the exits are. We'll have a quick overview of Taggle. Now, I know I do this with most of the webinars, but the reason I do it is because we don't always have the same crowd tuned in. So it'll be very brief. And indeed, I do try to change it a little bit as we go. There'll also be a bit of a description of Taggle's low power wide area radio technology. I'll follow that with more on network management, what it takes to manage a network. And then I'll get into network as a service, what it really is and what are its benefits. And finally, if you have any questions that haven't already been asked, we'll get into those. So moving on. Taggle as a company got started 13 years ago when Gordon Foister, the good-looking one on the right in the photograph, and a couple of others got together to do something new. He and his colleagues had been very involved in the development of Wi-Fi as we know it. The company they worked with, Radiata, was basically the first to bring high-speed Wi-Fi chips to the market, taking the technology that had been developed by CSIRO here in Australia and putting it into chips and making it available for things like now mobile phones, tablets, and other devices. So the company has a very strong background in radio communications. Originally, Gordon and his colleagues were setting out to develop a cattle tracking system. Gordon is a farmer and was sick and tired of traipsing all over his property looking for cattle, and figured that there must be some clever way to use radio to track cattle. And what they came up with was a low power radio technology, which is well suited to the task. Unfortunately, farmers aren't well known for spending money, and it hasn't yet been possible to make the cattle tracking solution low cost enough to suit their pockets. So in order to survive, the company pivoted to automatic meter reading in about 2010. And just for interest, what's shown in the pictures below are one of the first, if not the first, receiver, which is actually a computer with some extra boards inside. I think that might have been installed up in Queensland. I'm not too sure. So fast forward to today, and Taggle obviously is quite a bit bigger than it was way back in 2007. We currently have, amongst our water utility and council customers, about 45 entities. And the primary use of our network at this stage is for collecting water meter data. That is hourly reading of water meters. There are other sensors on the network, things like sewer overflow sensors, sewer level sensors, rain gauges, pressure sensors, and various others. But they all use our Taggle network to send their data back to the cloud and have that data then delivered to the respective customers. The data is used primarily to resolve water leaks and for billing purposes. As more and more councils and utilities get into it, they are also reducing their lost water, their non-revenue water, and it is also helping, the data is also helping them to plan for the future operations of their networks, right sizing of pipes, right sizing of meters, and other things. We have a bit over 200,000 devices. I think it was 207,000 devices operational on our network at the moment. I had a look yesterday. And last year we delivered about 1.7 billion sensor readings. And this year I'm expecting, actually I'm planning to set up a bit of a what's the word, competition in our office to see who's going to guess the date at which we roll over to 2 billion sensor readings delivered in a year. So we've come a long way from 2007, and I'll go on now to describe a little bit more about the background of it all. Just in case you're interested, you could look at these customers here and see who's who. I would draw your attention to the fact that there is a lot of white space on there, so if you'd like to get onto the leaderboard, this is where you do it. And finally, a quick overview of the network topology. Some of you have seen something like this before, but on the left-hand side, you have the various sensors. Shown are a few smart water meters, but they could be any of the sensors that we support. The data from those is sent to a Taggle receiver. That's a very clever piece of kit which is installed typically on reservoir sites or other elevated sites within our customers' asset base. They collect the data, and then using typically a mobile phone backhaul setup or perhaps satellite, we send that data back through to the IoT cloud, where we deduplicate that data, clean it up, and then ship it off to our customers where they can use it in whatever applications they want to use it in, whether it's billing or GIS, hydraulic modeling, anything at all, SCADA systems, for example. And looking a little bit more closely at the Taggle network, each one of these blue tags represents a single Taggle receiver. So you can, that picture I think shows approximately 470 receivers when I downloaded it a couple of days ago. So it's quite an extensive network, and it takes quite a bit of time and effort to manage that network to make sure that they're all operational, or as many of them are as operational as they can be, to ensure that we collect data reliably and deliver it according to our KPIs. Thanks for your question, Josh. Yes, I do. Taggle's low power wide area network, it's referred to as a spread spectrum technology. And what that means is that instead of transmitting at just one single frequency, we're transmitting at a number of different frequencies within a band, and they're hopping all over the place. This technology was actually developed back in the 1940s to help with the guidance of torpedoes from submarines. But nowadays, it's widely used in communications, particularly in mobile phone networks, and also by the military. One of the advantages of this type of technology is that it is very immune to noise. That's not to say it's completely immune, but it does have significant noise immunity. The technology that was developed by Taggle, it really is designed specifically for collecting small amounts of data, usually at long distance, but always with low power. The whole point of the exercise is to keep the size of the batteries at the endpoints as low as possible and to have them last as long as possible. So it was really imperative that the power consumption of all of the endpoints was at an absolute minimum. The spread spectrum technology is used within a certain band in the radio spectrum, which is referred to as the LPD band. That's the low interference potential device band. It's a class license, and I'll talk a little bit more about it later on. I should point out that the development of Taggle's technology to collect small amounts of data and transmit them very slowly at long distance was totally contrary to mainstream developments 13 years ago. If you can think back, we were moving from, I think, 2G into 3G at the time. And, you know, over the last 20, 30 years, the push in communications, radio communications, has been to send more data faster. If you think about our ability nowadays to send video across the world, complete with audio and all the rest of it, on your mobile phone. I mean, that's fantastic technology, but it does require a lot more base stations than we used to have. The push towards more data and faster has increased the number of base stations that are required. And if you look at 5G and the way it's being rolled out, pretty well there's one on every second or third street lamp. So, there's a lot of base stations out there. Can't afford to do that in the Taggle world. We need to have one receiver that covers, a range of approximately 1,000 square kilometers in open country. So what the guys did 12, 13 years ago was completely contrary to what was going on at the time. On that picture, you can see the current Taggle receiver with its heat shielding shroud. And on the right-hand side, then you can see just the guts of it. It really is a computer with some fancy radio gear attached to it, and becomes like a very big ear for radio signals. Here's what I would call our receivers in their natural habitat. This is just a collection of photographs showing our receivers in typical situations. On the left, you can see a couple of reservoirs. The one on the top is an ideal situation for us because it has the antenna up as high as possible. It has the receiver right beside it to give as little loss of that signal between the antenna and the radio receiver in the box. The other photographs are very similar, just same but different. Interesting one on the bottom right is a solar powered receiver. Because these things only consume enough power, or the same power, to power a laptop, it doesn't require a very big solar power system at all. I should also point out that many of our receivers are satellite backed. In the Northern Territory, for example, we have receivers that do their backhaul using satellite, simply because there is no mobile phone network in some of these outback locations that we operate. And at the other end of the radio signal, you have the meters and sensors that we connect to our network. These are just a few examples of the devices that we have installed around the place. And anyone who's looked at one of our webinars before will probably have seen these, so I won't dwell too much on them. We get into network management. I'll take a short break there while I have a drink. Hang on. Okay, so certainly over the years that I've been with Taggle, a number of water utilities have asked the question, why do we need Taggle Network? Why can't we just do our own? We already manage a SCADA network. We have X number of data radios, point-to-point or point-to-multipoint on our network. So why is it that we need somebody like Taggle to come along? And here are a few of the elements, if you like, of a SCADA telemetry setup that will be familiar to those of you that are involved in SCADA. Typically, an RTU or a data radio in the SCADA world uses a licensed frequency. Some of them might be microwaves, but the majority would be VHF, operating probably about 450 megahertz. Typically, they use licensed frequencies, and that means that while you do have right to use that frequency and an expectation of little or no interference, you do have to pay an annual license fee for that, which is fine if you only have a few radios. If you only have tens or maybe hundreds of radios, it gets a little bit more expensive, but you still have to pay that license fee. And with the tens to hundreds of radios that need to be managed, that's quite a workload, particularly for a SCADA system where it needs to be operational pretty well 99.99% of the time. And for many utilities, what they find is that if they don't have somebody specialized on their staff, they may need to go to a local company for communication support. Moving across then to something like Taggle, which is a low power wide area network type technology. It, like a number of similar technologies, excluding NB-IoT, which is based on the mobile phone network, they use the so-called LIPD band, the low interference potential device band, which are class licensed frequencies. Now, these frequencies are there for pretty well anyone to use, as long as they follow certain guidelines in terms of the type of signaling that they use or the power output that they use, and so on. But one of the downsides is that despite the name, low interference potential, there is actually a potential for interference, and that needs to be managed. There is no annual license fee for the LPWAN band, which makes it very attractive to a lot of people. And on that band, Taggle currently manages in excess of 200,000 radios, as I mentioned earlier. So when you consider that it is basically publicly available spectrum, in order to be able to manage so many radios effectively, you really need to have somebody who knows what they're doing. And I just point out that within Australia, we have approximately 10 to 11 million water meters. So, you know, the scope for growing these networks is huge. Now I'm getting into techie stuff, albeit in a minor way. This is a chart from the Australian Communication and Media Authority, and it is their frequency allocation chart. Looks a bit complicated, but the LPWAN band that I mentioned sits just in here, just about there, and it operates between 915 and 928 megahertz. It's not particularly wide, but for the sort of stuff that we do, it's perfect. It also sits in the middle of the mobile phone band. That is to say, there are mobile phone operators below that frequency and also above that frequency. So as I mentioned, it is a class license, so there's no cost. It is used by other players in our field commercially, but it's also used by hobbyists and many others. And the potential for interference is reasonably significant. It does require a bit of management to be able to use it commercially. So, network as a service. When I was preparing these slides, I thought to myself, well, how am I going to explain what network as a service is? So I did a bit of research and came up with one definition that's sort of pretty close. Network as a service is a business model for delivering enterprise-wide area network services virtually on a subscription basis. Now, obviously, this is probably referring to things like cloud-based services and so on, which many of us now use. But actually, when you think about it, network as a service is not a new idea. Water, electricity, roads, internet, telephones, and lots of other things are actually delivered as a network as a service. So those of you who are looking from a water utility perspective, it's no big surprise that what you're actually doing is operating a network as a service. It's a long time since we as a population had to carry our buckets down to a river or a creek and gather our own water. Somebody saw benefit in having a network as a service established for the delivery of water, whereby we can now turn on our taps and hey presto, there it is at $2, $30 or whatever, sorry, $2.30 for 1,000 liters of food grade material. Fantastic. So people in the water industry should not be scared off by the whole notion of network as a service. What a network as a service requires is quite a bit of skill, expertise, and tools. And so whereas the folks in the water utility space obviously have their various people, their hydrographers and their hydraulic engineers and plumbers and operators of all sorts, so too does Taggle. We have quite a collection of technical characters within our team who bring their skills and expertise, and we provide the tools to manage the network on your behalf. And of course, the big reason behind network as a service is all to do with economy of scale. I might mention it later, but I'll certainly mention it now. It's probably better to have one small team managing, in our case, 470 receivers on behalf of 45 water utilities than to have part-time or perhaps less skilled operators at 45 water utilities trying to manage one small network amongst themselves. So why network as a service? Well, the first area in all of this is network planning. One of the things that we do when we start off deploying our networks is we do a desktop survey, which is basically done on Google Earth or similar. And we're looking for obvious obstructions, topographical obstructions to our network, and trying to identify where are potentially good receiver sites. Working with the water utilities gives us an advantage in that where you want to put water reservoirs is typically where we would want to put receivers. So that works out pretty well for everybody. But it's not always the case. Once we get that network deployed, it's ground truthed, if I could use that term, at the time of deployment, in that every sensor and meter that we roll out, we do some signal testing at the site to make sure that at the time of delivery, there is a good signal from each and every sensor so that we can collect data reliably. And then as the use of the network progresses through the many years of service delivery that we offer, there is constant monitoring. There's ongoing spectrum surveillance where each receiver, for example, conducts a network scan, or sorry, a spectrum scan 3 times a day. And this data then is used to identify any problems that might exist within the network. Now, typically problems are those of interference, where something happens within an area where something has changed. Somebody's introduced a new radio, for example, or a new mobile phone tower has been installed, or some other thing like that. Once we have identified those problems, it's up to us then as a network manager to address those problems. We have a number of ways of doing these, from as simple as, for example, using a directional antenna, which we can point in a particular direction away from the source of the interference. It may be that we need to employ some filters, cavity filters, for example, which are very useful when it comes to mobile phone towers. And I have an example that I'll show in a few minutes. It may also be that we have to employ what we call active interference cancellation. Now, some of my technical colleagues will cringe when I liken it to noise cancelling headphones. But to the layperson, that's effectively what it is. It's just filtering out those signals that you don't want to hear on your radio and allowing you to hear the things that you do want to hear. When we do have a source of interference, it's incumbent upon us as the network manager to find out what the source of that problem is, and then to go and tackle the problem in a sensible way. It might be that we just go and talk to the operator of the interfering station and work out with them how to minimize the interference between them and us, or indeed us and them. Or it might be that we have to get a little bit more assertive and take the matter to the Australian Communications and Media Authority, the ACMA. They ultimately have the task of managing the use of spectrum, and if there are people who are in a very obvious or perhaps aggressive way using spectrum where they shouldn't be, well, they then become the arbiter of all such matters. All of these things are addressed by Taggle's network management team. They're based here in Sydney, and well, to put it simply, they're a collection of very skilled and experienced professionals from around the telecommunications world, and indeed the military, who operate our network on a day-to-day basis. They manage it continuously. They have some automated processes that allow them to be advised of any issues very quickly, so that very often we know about things that are happening in our network before it has an impact on our customers, which allows us then to be able to maintain our data delivery KPIs as best as possible. So I've got 3 examples of the sorts of things that our network management gets involved with. This first one is in Queensland. It's the town of Moranbah, which is bang in the heart of Queensland coal country. If you look at this screenshot from Google Earth, you'll find that there are 4 blue tags, or 4 blue dots. They are Taggle receivers. And in an area such as this, which is not very big, we would typically only require 1 receiver. But the challenge in this particular area is that there are mine sites on either side of the town, and they use a particular communications link to link one side of their operation to the other, which goes right across the middle of this town. And so their operations were having a big impact on our ability to be able to collect data from the many meters that are installed in Moranbah. So after a lot of discussion and experimentation and working with various people, we decided that the best way to approach this was to employ more receivers than we would normally, and to fit those receivers with what are known as sector antennas. That is to say, they're antennas that are very directional, and so they only cover a small area, and they are aimed in a particular way so as to exclude the interference from the mine site, but at the same time enable us to collect data from the various meters in Moranbah. This next one gets a little bit more technical, and I might have to employ a mouse for this. But what we're looking at here is some spectrographs. And this one here is the one of interest. What you see here is the area in which Taggle operates. I can't remember which of these lines it is. I think it's the purple lines is our area of operation. The pink one is a cavity filter, and the green one then is the it's another type of filter that we use to make sure that we don't get outside our band. We have to be very careful in terms of how we operate in this band. So what we're looking at is this area here being where we operate, and out here, this lobe here and this one here, they are actually mobile phone signals from outside of our normal band. But because they're so close and so loud, what they're doing is they're causing a lot of interference and noise, which you see here. So by using one of our cavity filters, which is now seen over on here, you can see that what was over here is now completely gone, as is the one here. And you now have a very clean looking Taggle signal, which we can then pick out, grab all the data, send it to our customer. So just the use of that single cavity filter has enabled us to operate in an area which was swamped with mobile phone noise and to operate effectively. This is another example. This one involves what we call in-band interference. I mentioned earlier that the purple lines indicate the band of our operation, and you can see that there's a massive spike here in the middle, which is causing all sorts of problems. And so what we've been able to do here is just employ a bit of discretion, and discretion is the better part of valor. What this signal actually was a differential GPS antenna employed by a local farmer to help him with guiding his tractors and so on. So rather than cause any issues, it was decided that it was commercially better for us to simply pick up our receiver and move it some way away from this tower so that we weren't picking up its signals. And over here you can see how we're coming back to a nice clean Taggle signal again. But those are the sorts of decisions that our network operations center have to take on a daily basis in response to the various types of interference that we might pick up along the way. So getting towards the end here, the benefits to our customers of our operation of a network as a service is not John and Jawed, our two-star project management type folks. The benefits really boil down to the fact that when we roll out our networks, they are tailored to suit our customers' requirements. That is to say, we know where you want to put your meters or your sensors or whatever they might be, and we know where network coverage is required to be able to pick up signals from those sensors. I make comparison here with the mobile phone network. If you have a mobile phone and you can't get a signal, you know that you can move inside the building or outside the building or around the corner or wherever it might be and get a better signal. You can't do that with a meter. You either have coverage or you don't. And just for the benefit of those who might be considering NB-IoT, just be aware that if where you want to put your meters isn't covered by the mobile phone network, I wish you luck with your mobile phone companies getting them to put an additional tower in. At Taggle, of course, you tell us where you want coverage and we put it in. I've mentioned the skilled work done by our colleagues, so I won't deliberate on that further. What is of great value to water utilities particularly is that you don't need extra resources to manage what is obviously a very complex radio network. As I mentioned before, far better to have a team of people who do this nationally than to have a whole bunch of part-timers dotted around various water utilities struggling to keep up with it. It means then that you as a water industry professional don't have to be distracted by day-to-day network issues. Really what it all does is it allows you to go and focus on using the data, not on collecting it. And using the data is really what this is all about. You can spend as much as you like collecting data, but you're not going to get any value out of it unless you actually sit down, analyze it, do what-if scenarios, and come up with some actionable items to make better use of it. John Quinn, our managing director, is very keen on this particular phrase, one throat to choke. Taggle Systems, in its delivery of network as a service and all of the devices that go into collecting your data, means that we are responsible for the whole thing. Whether it's the sensors on your meters if it's the radios on your sensors and meters, through to our networks, through to our cloud operated systems. If you have any problems, it's one phone call. You call us. You don't need to call Telstra. You don't need to call the blokes that made your sensors. It's just one throat to choke. And that pretty well is it for this afternoon, ladies and gentlemen. Does anybody have any questions? You might have to unmute yourselves to make that happen. No, I don't see any questions on the chat line either. Okay, if nobody has any questions, I'll move on to the next part, which is about our upcoming webinars. We are getting a little bit stuck for topics to talk about. And so if any of you have any ideas as to things that you'd like us to address, questions that you have, ideas that you want considered, then maybe you can drop us an email, send it to inquiries@taggle.com.au, and we'll certainly be happy to entertain all sorts of ideas. The next webinar, as far as I know, is next Wednesday afternoon. Like they used to say on the TV, same time, same channel, 3 p.m. next Wednesday afternoon. And that will be promulgated, if you like, over the next few days when the next topic is decided upon and prepared. So with that, I'll leave you all to your afternoon and wish you a good day. Thank you very much.